In this video, we're going to do some more examples of inverse functions. So that means we're going to be considering one-to-one functions or trying to make functions one-to-one. So let's go to the first example here was to do with the identity function. So we wanted to, the identity function is the function that doesn't really do anything. So it sends the input to the output, which is the exact same as the input. So we're going to be composing the function that I picked here with the identity function. So first of all, let's do I compose with f of x. So that's going to be I of f of x, which is I of 2x over x plus 1 for my choice of f of x. Okay, now when I do I of this is like my input, and what I do is I just put that in for all the x's in the formula, which is just that one. So I get 2x over x plus 1, which is f of x. Okay, now if I do it the other way around, so f compose with I of x, that's going to be f of I of x. Okay, now I of x is just x. So maybe I should. So I of x is the same as x from the formula here. So that's just f of x, which is 2x over x plus 1, which is also f of x. So we see that I compose with f is the same as f compose with I, and they're both f. So composing with this identity function doesn't do anything. You just always get the function back. Okay, so that's the nice thing about the identity. Now, so the inverse does the opposite of what the function does. So if f sends x to y, then the inverse is going to send y back to x. So you can see that the domain and the range are going to swap for the inverse. Because the inverse is undoing what f does, when you compose them together, you're going to just get the input back. So essentially, they cancel each other out, okay, no matter what order you do them. So if we have the function f of x is x cubed, then the inverse is going to do the opposite. So if x cubed, so f of x, cubes the input, the number, so the inverse should do the cube root. So it does the opposite. Okay, so then f of f inverse of x is going to be f of the cube root of x, which is going to be the cube root of x cubed, which is just x. Similarly, f inverse of f of x is going to be f inverse of x cubed, which is going to be the cube root of x cubed, which is also x. Okay, so these guys are inverses, inverse functions. And so when we compose them together, we get x. Now, when we did this other one, we said that they were not inverses because of the function x squared not being one-to-one. I just want to make a comment here. If we restrict the domain of f of x to 0 to infinity, so we only let you plug in positive numbers, then f of x is 1-to-1, and f inverse of x is the square root of x. Okay, so if you make that little adjustment, so instead of, so if we had the graph, so if you just take 1/2 of this parabola, okay, so we're getting rid of that half, okay, then it passes the vertical line test, so it is invertible, and the inverse would be the square root, which would look like that. Okay, maybe I actually should have done it on the same graph. in a different color. Okay, so this one goes through the point 1, 1. Okay, which also does the square root graph. Okay, so it's going to look like that. And then, because we've already done the other part, we know that this is the graph flipped over the line y equals x. Okay, so now that it's 1 to 1, you can talk about the inverse, and it would be what you think it is, okay, because then you wouldn't have that ambiguity. We would know it's not -2 because -2 wasn't in the domain. So then we know that it could only be 2 if you want the inverse of 4. So it tells you exactly how to send things back. So sometimes we do that for functions that are not 1 to 1. We can restrict the domain so that we can force it to be 1 to 1, and then we can talk about its inverse. Okay, so let's try and find some inverses here. So let's do this example 1. So we would write it as y equals x cubed plus 2, and then we switch. So it's x equals y cubed plus 2. Okay, and then we want to solve. So I'm going to move the 2 over. So x minus 2 is y cubed. And then I can take the cube root of both sides to find y. So that means that f inverse of x is going to be the cube root of x minus 2 here. Okay, so here, this part, what we're doing here is the solve. Okay, one more. So we had y is equal to 3x over x plus 1. So we do the switch. So that's x equals 3y over y plus 1. And then I want to resolve for y. So I'm going to multiply both sides by y plus 1. So I have x times y plus 1 equals 3y. Expand the x through, so I have xy plus x equals 3y. I want the y's on the same side. So I'm going to subtract 3y on both sides and also subtract x on both sides. So I get xy minus 3y equals negative x. Now I can factor out the y, and I have x minus 3 on this side. And then I can divide by it. So y is negative x times x minus, or divided by x minus 3. So our function's called g here. So that means that g inverse of x is negative x over x minus 3. Or you may have gotten, if you bring the negative to the bottom, you may have x over 3 minus x. Those are actually the same. Okay, so yours might look like that instead, depending on what side you took things to. Okay, but both of them are the same. Okay, so when we did example 3 just now, let me just rewrite it. So g inverse of x was negative x over x minus 3. So that means that it has domain of g inverse is x not equal to 3, which means that the range of g is going to be y not equal to 3. Or in interval notation, negative infinity to 3, and then 3 to infinity for y. So because we already found the inverse, it's much easier to find the range here by finding the domain of the inverse. Okay, I think we just have one more graph to do. So this is the graph of y equals 2x, which is actually a function we're going to talk about in the next section. So I'm just going to label some points here. So this is the point 2, 4. This is the point 1, 2. 0, 1, negative 1, and 1/2. So when we want to graph the inverse, what we're going to do is switch all the coordinates. So instead of 0, 1, we're going to have the point 1, 0. Instead of the point 1, 2, we're going to have the point 2, 1. Instead of the point 2, 4, we have the point 4, 2. And instead of negative 1, 1/2, we have 1/2, negative 1. And, in fact, so here, there's a horizontal asymptote at y equals 0. That's going to translate into a vertical asymptote of x equals 0. Okay, also, the domain over here is negative infinity to infinity, or all real numbers, which means that the range over here should be all real numbers. And here the range is y values bigger than 0. So that's actually going to be the domain over here. So we're going to have the only x values that are positive. Okay, and then our function is going to look like that. So this is the inverse. This is y equals f inverse of x. Now when we get into section 6.4, we'll know what this function actually is. Okay, but for now, that's what it looks like. And all you have to do is replace each of the points. Now, if you did draw them on the same graph, and you look at the line y equals x, okay, it's going to be a reflection over that line. Okay, so that just so you can't really see that on two different graphs, but that is what would happen. Okay, so you can see that they, the domain and range also switch when you're talking about the inverse function. So that is some extra examples to do with inverses.